links and pixels. Here's one example of a customization. This is a basic like particle system that represents the depth cloud, the depth array from the Connect, and this mod just kind of makes it a little more swooshy, gives it some kind of 80s effect. To any of you who might have used WebGL before, this is using the 3JS library. So anything you can do in 3JS, WebGL, you can add, take the data from the Connect, make something really awesome with it. So let me bring up the website. Oh, I am not connected. That's a problem. Let's see. Well, here's the website.
Nice. .xyz.
Actually, I can bring it up in just a second. Unless you're raring to go over.
Oh no. Still trying to recover from everything falling apart on us.
I smelled smoke.
Is it plastic smoke or metal smoke?
It's kind of like, yeah, like the plastic wire smoke.
Is that magic smoke?
Yeah.
Here, I'm going to fake this real quick. There we go. Yeah, so commotion.xyz is the project page. Here's the hackathon mentioned. Attendance is free. There's an RSVP link here. Come on down for a few hours, make a really cool visualization that hundreds or possibly even thousands, I think there's about 20,000 attendees to SparkCon can come by and interact with. If you have any questions, feel free to grab me after Burr's presentation.
Just a suggestion. You should have one of these things that morphs into that pin display, like you pushed into it.
Yeah, can you push your hand?
Yeah, I was just thinking as I saw you. Yeah.
All right, let me see if I can set this down so I don't have to sit here and hold this the whole time.
Okay. Oh.
You're being videotaped.
Oh my.
Do you have the no sleep on?
Oh, I have to get my battery.
Well, I'll tell you what. How long do we have?
How long do you need?
How long when do you guys have to go home at night?
I have to stay here until you all leave.
Yeah.
How's
Too
that?
bad.
When do the babysitters call and say, hey, get your butt home?
No children.
My wife?
Hey, she might kill you if you don't come home soon. All right, so is this thing not on?
Oh, I forgot to plug the VGA cable back in.
So because I'm trying to get things configured because I made a change that blew everything up. You were going to get a chance to see things getting configured together too. All right, so this is my.
Everyone loves a good war story. Tell us what went wrong.
The good thing is I break a lot of notes for all these things. So let's do my 2650 over there. All right. In any case, before we get into all the crazy demos and whatnot, actually I'll show you a demo up front. So let's see if this will work. Because really, I just made a bunch of changes. This guy right here. All right. So most of the stuff I have up here, by the way, is running Node.js. So the whole idea that I was working on is can use JavaScript to touch the physical world, right? Everyone knows JavaScript runs in a browser. But with Node.js, you actually can run it on a lot of these different devices, and then you can actually interact with whatever you want to interact with in the physical world. And so if you think about that as a software person for a second, as software people, the most interaction we've had with the physical world was keyboard and mouse in most cases. And there were some really clever people that knew how to make the CD drive go in and out back in the day. Remember those folks, right? Because they did that because they had to, power cycle the server across from it. You've heard this before, right? That was like how they actually dealt with their DevOps solution was they had to power cycle the machine so they actually knew how to run the script to basically cause the CD drive to pop out, had a pencil taped to it, and pop the power button on the server, come back in, and then power cycle the machine. So that way they didn't have to go down and power cycle the machine. So this is kind of what we're talking about now. So it's the modern version of all that. How about that? So what's happening right here, let's see if this will work for me. If you can read kind of sort of what's happening there, you'll see it says 251, hello beacon 251. So what this guy is a Raspberry Pi running on my battery right here. And he's got a Bluetooth dongle right there, the green guy, and he's got a Wi-Fi dongle. And he's primarily serving as a gateway device that's looking for Bluetooth traffic, seeing if he can identify the Bluetooth traffic by hitting a REST URL, again, another node service that we have running up in the cloud right now. And then if it can pull the name, it'll display the name. Now in this case, 251 doesn't have a matching name, but let me go ahead and get this guy put back together. All right, so we'll let him boot up. But what we're talking about here is this little thing right here. All right, so that's 251. We actually labeled it so we could know it better. This is a Bluetooth low energy beacon. This is the same technology you find in your Fitbits and all those devices you hang around your neck to talk to your phone, right, from a wireless whatever kind of thing. So all that Bluetooth technology that's happening out in the world right now, you can sense it. And then based on those sensing of that data, you can do something with that data. So think about the use case here. If I own a mall and I want to know everybody in my mall wearing a Fitbit, I can, and I can track all their whereabouts throughout my mall. That's what this means. And so what we've done with this, and okay, good, it's coming up correctly. So if you notice, let me get this one further away. Okay. Because, see where it says Burr Sutter right there? Hello, Burr Sutter? This one's mapped to me. So this is 101, and it's mapped to me. And I threw the other one further away because it's actually looking for the ones closest to it right now. So it has this concept of distance also. All right? So again, a battery-operated Bluetooth low energy device. These are not particularly good ones. They're $5 each. They're kind of crappy. So they only last about 6 days on a watch battery. So I have one of the batteries sitting over here. Let me try to get this out of the bag so you can see what I mean. This is just a watch battery, a coin cell battery, so that size. All right. But it's really not that good one. It's called the Gimbal. We used it because we gave away 300 of them at Red Hat Summit this year. So if you see what that thing's doing, you see it's displaying my name. So using that concept, all right, 300 of these, a bunch of Raspberry Pis connected through Bluetooth and Wi-Fi, we were able to basically produce this data set for our conference. So basically, we'll just watch this little video here. So it's doing, and this is actually, this is an RxJS real-time map. We actually use the map to test the system as we walked around the conference. So we were walking around with our beacons and actually watching ourselves on the map. Because what's happening is we put scanners in these rooms, and what you saw there was everybody went to breakfast, everybody comes to breakouts, everybody goes to different breakout sessions right here on the second floor. And then eventually, we were showing this at our keynote demonstration. You can see people started eventually coming to the general session. And it's basically, it's 1,600? I can't remember. Let's see. But this is just basically tracking all throughout the day. Yeah, now you can see everybody coming to the keynote at 1,600. And this is our presentation. And then people leave our session. And then they kind of come back for the Jim Whitehurst session. And then eventually you watch them go. I recorded this in the middle of the night. So you will eventually see people leaving the building as the conference is wound down for the day. You see them going out here. So, and you might see a couple people we've lost on the map left at the end of the day. Well, and actually you can see it's 22:15, so this 10:15 at night when I got back to the room and I did the recording. But this is an example where you simply used just these little guys right here, and we basically asked people to carry them around, and we were able to track their whereabouts throughout our conference. And I make this point because this is what I mean by touching the physical world, or the physical world interacting with you now. And that was, in this case, this particular code base was, what's running on the scanner right now is, in fact, C++. In that case, we wrote C++ for that. But we collected all the data, moved it into our message broker, aggregated it all into a message broker, and the message broker fed Apache Spark, right? So Apache Spark is the real-time streaming complex event processing system. That's what determined, based on the signals we were picking up from this, it took the raw data, which is about 9 million events that we received in the course of this. What you saw here was about 9 million transactions. And then we actually then said, okay, what room are you really in? Okay, because we could figure out, okay, now you're closer to this one or closer to this one based on that approximation of distance that you can do, calculation of distance. And then we loaded all that to a Node.js server. And then this is, like I said, is an RxJS-based map. And so basically it's doing real-time streaming to this map. And like we were walking around with our laptop and our beacons just to see if it could track us around the building. And that's how we tested it. You have a question, sir?
Yeah, so if it's all based on distance, how do you determine check-in or check-out between the different, because I assume those are between different rooms, right?
Right. So we actually had a lot of fun with that. We had to think pretty hard about that specific problem. Because actually, these guys performed way better than we thought they would. We thought that once we got into this big old concrete building with big old massive walls and everything, that only one room would really pick up on the beacon. In fact, 2 rooms picked up on every beacon almost every time. And so when we first got there, you would actually see a ding, 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 back and forth. And that was Apache Spark going, okay, you look close here. No, you're there. No, you're there. And so we actually had to tune it just a little bit. It was just an algorithm that we had to tune on the Spark side. Basically, okay, so be a little less sensitive, right? Just assume, look for that thing that's a little bit closer. And basically, the check-in, check-out events are specifically, if we see you enter a room, we just thought that was a check-in. If we see you leave the room and enter another room, we saw that was a check-in, and we assumed a check-out. We also put scanners in this part of the hallway here and this part of the hallway here, so that also indicated to us that you checked out, if you will. We actually didn't spend hardly any money on this. We had no budget. So I personally bought these things and expensed them. Probably, does anyone else work for Red Hat? You didn't. So I just went out and bought these things. My counterpart in crime here was Scott Stark. He bought the Raspberry Pis, and we basically set it all up. We spent about $2,500 for the system. And the marketing people have kind of gone crazy. They're like, "Oh my God, that's amazing!" Think about it. You as an organizer can now know where your people are. You can know where the hot spots of your conference are. You can know where the popular sessions are, the unpopular sessions are. If you run a mall, you can know exactly where traffic flow is to the mall. Therefore, you know exactly where to stage your advertising. You know where to sell that piece of floor space, that kiosk, or that particular store, at a higher rent level, because you know that's where the people actually move. So this is why this whole Internet of Things, in my mind, is going to be fairly interesting. There's a whole lot of money involved in this data once you know how to sense the physical world. And so that's kind of just my preamble to getting into the presentation. How about that? And I want to show you that because, all right, so we'll run some slides here. And then I got a bunch more things to show you if it all works. We'll see. All right, so I call this the enterprise developer's journey to the IoT because I consider myself to be an enterprise developer, meaning I work on enterprise class systems and enterprise systems, meaning in large enterprises. I've done a lot of consulting work. These days, obviously, I work for a vendor, but that's kind of my focus. I'm not a game developer. I'm not a web developer in the traditional sense at all, other than if you think it from an enterprise standpoint. I've mostly been a Java developer most of my career, but I've done a lot of Node.js stuff for the last couple of years, mostly because it's a lot of fun to hack around with. And all these other demonstrations I'll show you are Node.js based. So that's why I focus on the enterprise aspect. Okay, so I'm hoping many of you folks aren't necessarily game developers, and many of you aren't necessarily mobile app developers sold to the App Store, and I'm hoping many of you aren't necessarily, working in some little startup trying to do the next cool Airbnb. I'm hoping many of you are enterprise developers, right? And you can think of it, and that's the perspective that I have here. If you are a game developer or mobile app developer for the App Store or next Airbnb killer, I think you'll still find some content here that you'll enjoy as well. But the secret sauce to all of this is we as programmers, especially Node.js programmers, which I hope many of you guys are. How many people are Node.js programmers in the room? Oh, not that many. So most of you on the JavaScript side are more client side, I guess. Well, it's the same code, just a little bit different, write it on the server side, and now you can talk to the physical world. And if you actually watch what Google's doing with Chrome, they're adding a lot of stuff into Chrome also, which is kind of crazy to think about it. Okay, so before software ate the world, you guys know this quote? The Mark Andreessen quote? Before software ate the world, we actually used to build things, right? Think about it. 20, 30 years ago, there was a manufacturing industry in this country. We used to make stuff. Not only do we make it, we distributed it, which is actually the world I lived in. I was a little bit associated with manufacturing for the software that I wrote, but I did a lot in wholesale distribution. Those are all the people that put the stuff in vans and trucks and move it around the country and get it to the little mom and pop store before Walmart put them out of business. And then you would actually have stuff that people would buy. So really, and I say this and I'm being kind of funny about it, but how many people here kind of sort of work for either a software company or financial services company these days? We're sitting in the middle of a financial services company, right? All right, fantastic. You'll notice there's a lot of people more or less in the software business now. It used to be there was a lot of hardware, if you will. And so the cool thing is, how many electrical engineers, by the way, are actually here? Okay, one gentleman here. You'll find more in a lot of the computer science crowd, or the software crowd, I should say. Well, this is where that world comes back to life, okay? You can now actually have your software talk to physical things. We're going to show you a lot of examples of that. But this is a Allen Bradley PFC. No, is that right?
PLC.
PLC, there it goes. Programmable Logic Controller. PFC is private first class, sorry. So, basically this is what would control the robotics and things like that on the line, the manufacturing line. And so if you had very special sensors to determine if the widget or gadget was out of shape or out of size or whatever, you had to go left to right, or you had to slow or speed up the conveyor belt or whatever, those things were particularly powerful for that. And they cost like $8,000, $9,000 a pop. And once you put them in place, you never want to take them out. And so my brother-in-law works in manufacturing. He still has tons of these things in the plant that he's the engineer for, as an example. This one's particularly interesting to me because I actually know the guy who used to go and fix these things in the field. This is actually a vending machine, and this is real. So if you actually work for a very large hospital, you have a vending machine for clothing because all the doctors and nurses have their scrubs and allotment, and therefore they have their badge and their ID, and they can go to the machine and get their next set of scrubs that they need to wear for the day or whatever. And then, of course, they have an allotment, and they have to kind of keep up with inventory. But it's a fully automated vending machine for clothing that hospitals use as an example. And like I said, I had a friend who was literally fixed the machine physically when the actuators and servos and whatnot didn't work correctly and made sure their logic was correct. This is a portable ultrasound machine. The reason I use this as an example is think about the little beacon thing we just did here. What if this guy gets lost in the medical facility? Because they actually do, and they don't really get lost. It's just that somebody wheeled it to patient room X, and they can't remember which patient room it was in. But now that inventory, this 10,000 or 100,000, whatever this thing costs, machine is kind of lost. Well, with all this beacon kind of technology, you can kind of know where it is now. You can know where your forklifts are. You can know where your big, expensive machinery is. You can kind of know where stuff is. Yes, sir?
I mean, has there always been that kind of technology to enable that type of location of devices with RFIDs and all sorts of other prior technologies?
Exactly. So the question always comes up, what about RFID? RFID has been out there a long time. Funny enough, RFID is actually enjoying a renaissance now with the whole Internet of Things again. People are like, talk about RFID. There's a reason why we didn't use RFID for our tracking system, and I wouldn't necessarily use it for this style of tracking system. RFID has a range of centimeters to inches. You literally have to get physically close to the sensor for it to pick up because it actually has no battery in it, and it's using the sensor's energy to energize it. So you have to get physically close, and if you don't get physically close, you have to build an antenna the size of the doorway. And that's, again, why we didn't use it for our use case. Those antennas cost $40,000 to $50,000, and often they're custom built. And so that would have made our little demo incredibly expensive. So RFID has its limits, as does the Bluetooth trick, right? This runs on battery, and batteries do run out. But I have one example here, wherever it went. It has a 3-year battery. So, you could have to decide, okay, it costs more. RFID, is less than a penny, and my 3-year battery version costs $29. So you might decide, okay, $29, can't deploy a lot of those. 3-year battery, I don't want the headache of changing out batteries. Maybe go with RFID, but then I know I need to get physically closer to the things that I'll be looking for. So just a different, similar use case, but just a different technology. We used to send out people in trucks. They would fix things up in the, power lines and things like that. Come to your house and make sure that, you had power and water and cable, maybe not cable, right? They don't necessarily make sure that you have cable. They may or may not help you. But here's my favorite one that I threw on the slide because I thought it was actually great. So people have heard of Disney World, I'm sure. How many people have gone to Disney recently and actually got one of these magic bands? Okay. Was your mind blown? And so for those of you who have not been to Disney World yet, at this point, as a technologist, you need to go. Okay? So this little gadget right here is reported, they publicized it, it cost them $1 billion. So think about that for a second. $1 billion investment for this little piece of plastic with some little electronic gadgets in it. The actual band itself, they'd probably get manufactured en masse for a couple bucks. That wasn't $1 billion. It was the entire infrastructure they built out and the complete reimagining of their entire enterprise information system to support it. Because what you do with this magic band now, all right, it has 2 radios built into it. It has an RFID, right? So that's if you're going to check into something, you literally will touch your band up against the sensor and it'll know who you are based on your unique identifier, and then you can get on the ride or get to the turnstiles. You can do that sort of thing. Get into your hotel room, order your food, charge your food, right? That's the RFID trick. But it also has 802.15.4. Well, technically it's a 2.4 gigahertz long range radio, identical to the Bluetooth technology I showed you just a moment ago, that has a small battery in it that lasts 2 years. So now, as you're riding the ride, they can personalize the experience to you because they know where on the ride, they know which car you're in, they know who you are. They can decide that your child loves Buzz Lightyear, and Buzz is going to come talk to you versus, one of the princesses or one of the other characters in Disney World, right? Because that's the character you love, right? I really want to, what was the one that, the Pocahontas character, something like that. I took my son Disney many years ago, and we had to go find Pocahontas. He thought she was pretty attractive. I was like, okay.
Is this story really about your son?
It was. And my nephew, though, he was really funny. We had a lot of photos of him and all the princesses. And so, okay, we found all the princesses at Disney World. But the idea here is that you can actually take this technology now and think about it. It's very simple electronics. It's very low cost now. And you can use it to reimagine your entire enterprise, which is what Disney has done. They can now provide a fundamentally different experience to everybody that visits their parks, and they have just started. You will never lose your child again in Disney parks. As long as they have the band on, they can find them in the park, just like we did with this Bluetooth trick. Same technology. But I didn't know about that when we did this. I kind of came up with this idea on my own after talking to several people actually at last year's All Things Open. So last year's All Things Open, I was going around to different people who kind of think about these problems, and we had these conversations, and we eventually came around to, hey, we can use Bluetooth low energy devices because they're cheap, and they're on a simple battery, and they last fairly long. So Disney kind of came up with the same kind of idea there. So this slide kind of puts things in perspective. I know it's way too small for you guys to actually read, but I use this content to kind of, I like to think in terms of history. I guess I've been doing this way too long. So 30 years ago, I used to build systems that were green screen. Maybe it was 5250, 3270, and actually I mostly did VT100 kind of things. Green screen, you basically would let the user fill in fields on the screen, and they would have to hit certain function keys to make things go, right? That was the way we used to build software way back in the day. And I call that the CUI, right? Character user interface. And what's important about that, though, is at that age of technology, what we actually had in the world is we actually had, in this case, the customer. Let's say the customer was a manufacturer and they needed more of your product to basically, as inventory for their product line or their manufacturing line. So they needed more of your paper, let's say, and they had to get the paper ordered from you. You would actually pick up the phone as a plant manager and call your enterprise sales rep. Hey, Joe. Hey, Jim. What's going on? Blah, blah, blah. I need more paper. Oh, yeah, I know you order paper every 2 months. I guess I should have remembered that. All right, I'll get the paper order in for you. That person would then write something on a fax piece of paper, fax it in to the back office person. The back office person sitting on the green screen would data entry that data, and it would hit this ERP, right? It would hit the enterprise resource planning system, and out the other end would come the paper and eventually make it out to the plant. That was how we used to have software. That was software. That's what we did. And there was a lot of problems with that. The conversation could have some error transmission in it. The person writing things down on the fax could have had some error transmissions in it. When it got over to the person doing the data entry, they could have made a small mistake. And then the thing that actually hits the end, that comes out the other end that actually lands at the customer site may or may not be what they really wanted. And then we went to the world of GUI, right? You guys remember the transition we did to client server in the mid-90s. We're going to do Windows-based client server applications, and I worked on these too, again for host-up distribution. I did both of these for distribution. Same kind of problem. And then we said, hey, we've eliminated part of the chain here, eliminated part of the time involved and the errors. We basically said, hey, sales rep, don't fax in the order to the back office person. We have a nice Windows-based application now that you're going to get a laptop. You type the order in yourself. And again, there's still those additional steps, right? They're still happening on the back end. There's still things happening on the back end where the customer calls the sales rep does the data entry, it goes into the system, out the other end comes, but there's still that additional step. Still opportunity for error. And then we had the web thing. And we said, hey, we did this web thing. Hey, customer, you put the order in yourself. Bypass the sales rep, right? We're still kind of here now. Bypass the sales rep. Mr. Customer, you know what you want. Pick it from a list of catalog items, put it in your shopping cart. and hit submit, and that order will come to you. And now we've been talking about mobile for the last few years. So now the customer doesn't even have to go to the desktop anymore to enter that order. If they walk by their machine, they look at their phone, oh, I need more X on their phone. And then more X hits the system. And the reason I have this kind of thing built this way is if you think about it when it comes to intelligent things, there's no reason for humans to have ever been involved in that transaction. The machine itself knows what it needs. It can know what it needs. It knows it's out of inventory. It knows it's out of paper of a certain size and certain type. It could have put the order in directly with nobody, no human involved in that transaction. And somebody here is thinking, oh my God, we're putting people out of work. This is what we do as technology people. We automate things, right? But I paint that picture because this is the world that this is the world I came from, manufacturing, distribution, and all those things. And this is really the software I built for people. There was a sales rep and a phone call and a back office person who did that, right? Get rid of the back office person, let the sales person work. Then, make it web and tell people you don't need salespeople anymore. We disintermediated all those people, right? That was the word we used to use, disintermediation. Then mobile, right? Well, now it's just the next generation. Let the things talk to things. So this is my developer journey. This is how I see it. And my goal, by the way, in this presentation is mostly to make sure that you guys have a feeling for what is possible, what might be doable. What does this world mean if I can now talk to the physical world? And so understanding what is possible, this is hopefully where we're all taking this journey together. And one of the things I make a point up here is that you need to make some friends. All right, so actually I've gone around to the Tri-Embed group, right? I've gone around to the local robotics group, spent time with all those folks. And I did the same thing back 3 years ago when I was doing mobile research, right? I spent time with the local Cocoa Heads group, which is the Objective-C guys, and I spent time with the Android folks. And, make some friends. In this case, you need to make some friends with embedded engineers and electrical engineers. Some of you were electrical engineers back in the day, right? So maybe you have to dust off those skills. And if you have these friends in your network, you can now understand how they work when they build firmware, they design electrical circuits and electrical systems. And then now that the world is looking at connectivity, they're figuring out ways to do Bluetooth, 802.15.4, and Wi-Fi as an example. And you can talk now. You can talk their stuff, whatever it is they're building, whether it be a robotic engine, whether it be some sort of motor, a DC motor running on a conveyor belt someplace, whether it be the electrical circuitry turning on and off the air conditioning, whatever it might be. But so make some friends and consider doing that. And then, like for my case, I'm kind of in this experimentation prototyping phase. I've tried all sorts of different things. I'm trying all the sensors I can find at a reasonable cost, as an example. I'm trying all the different hardware kits that come from all the different vendors, just to see what the behavior is. Once you get beyond this phase, which I haven't tried yet, you could literally box this up and deploy it to production if you wanted to. You could take the Raspberry Pi here and put it out in the field and let it work. That's essentially what we did for that Bluetooth tracking system. Now, we didn't intend to let it run for years or even, even weeks. We just wanted to run for 5 days. So it did. Ran great. We learned some things in that process. The Wi-Fi in the conference room was not that stable at the conference building, and we probably should just put them on Ethernet. And it would, and we actually had one scenario where you guys actually saw all those balls coming into the keynote room. And basically, and it was actually 2,000 people coming into the keynote room. We were only tracking 300 beacons though, because that's all we gave away. As the people entered the conference room, basically the Wi-Fi went down, because that's what always happens at a conference, right? And therefore, it actually looked like all the people were still in their breakout sessions, because that was the check-in, check-out logic, right? If we don't see yet another check-in, we just assume you're still where you're at. And so I'm sitting here right before we go on stage for 2,000 people, and I'm talking to the developers like, all right, the Wi-Fi has gone down. We're kind of toast. The map is completely wrong, and we got to show this map to everyone in the room right now and say, look, and you're all not here. And I was trying to come up with some jokes and whatnot. And it was really kind of bad. And so right before we took the stage, and if for anyone who was actually physically in the room, you actually saw me running across the stage right before the lights came on and everything else, because we actually made a code change right before the system happened. So we actually found an Ethernet connection that we happen to have an extra Ethernet connection because our laptops are on Ethernet, because we knew Wi-Fi would be a problem. We got one of our scanners, ripped it, took it off the Wi-Fi, put it on the Ethernet, rebooted it, so now it's streaming its data again. So we literally had just one of these guys, and actually I was using this battery. And it was pulling the data in off of Ethernet. And then all we had to do is basically change the coordinates on the map, make a change to the Node.js server, and restart it. And so we did that really right before the demo started. And it basically, as we got all the data collected through Ethernet, then we could basically redraw the map and show, yep, everybody's here. So my point with that is you can do a production system, though it might not exactly work out the way you want. Right? If you really want to be hardcore about this, these folks actually get into designing their own custom PCBs. That's literally where, if you think of this printed circuit board, just as an Arduino Uno, but basically you would design that yourself using something like EagleCAD, and then you could design exactly where all the circuits flow, exactly what chips, everything, every component that you need there, and design that. And you basically can now, these days, you can ask a third party to build it for you, manufacture it for you, within like a 24 to 48 hour turnaround for teens of dollars in some cases, like $12 to $30 kind of thing. And if you decide you're going to make like 500 of them or 5,000 of them, you can probably get them all for like $1 each, 10 cents each, depending on what you throw on there. I mean, really, once you go to scale, right, these things cost nearly nothing. And so that's, so if you want to design your custom PCBs, I haven't tried that yet, but I've definitely looked at several, read several documents on how the process, looked at several companies that were doing it. It's like, okay, this actually is pretty cool. So you could design the PCB, design exactly what you need, get it manufactured, and put it in your plant, put it on your trucks, give it to your service delivery people. The people who crawl up the poles or through the sewer, you could have all that set up on them, within a few months. Okay, and then you can also learn about these field programmable gate arrays, FPGAs, field programmable gate arrays. I didn't even know these things existed because I don't live in this space, right? But I've met some people now who's this is what they do, and it's actually pretty intriguing. And then if you do a little research on that, you'll realize that people like Facebook and Google and all are now trying to build their own specialized network routers using FPGAs. They want, in other words, they're trying, basically with this, you can design your own chip, right? And they're trying to optimize the chip for doing certain types of workloads. Yes, sir?
There are some companies like Cypress that have programmable systems on a chip that have merged the ARM CPU along with the field programmable gate array or the programmable logic cell, whatever it is, on the same chip.
On the same chip?
Yeah.
Yeah, it's
Makes
pretty
things
crazy
very
what
convenient.
it's pretty interesting what people are doing now. And again, it's not the world I come from, right? I was building character user interfaces, client-server user interfaces, and the web apps and mobile apps, and now this is a whole new world. But it's pretty cool and pretty fun. So I encourage you to think about these things. Like, okay, what does it mean to talk to the physical world? So this is high-level architecture. I don't want to keep you guys here all night, but this high-level architecture, basically you have sensors and actuators as two big groups of things, all right? So sensors, you're basically what I call reading the world. That's how I like to think of it, me as an old database programmer. I'm reading the world, all right? Actuators, I'm writing the world, right? Think of it like that. I'm just sensing, I'm just learning, I'm just understanding. I'm not really interacting per se, I'm just sensing, that's the sensor side. On the actuator side, you're taking some action. You're actually causing something to change in the physical world. So I have some simple examples, little robotics and things like that. That's the easy way to think of it. But anytime you've taken an action in the physical world, whether it be turning on a light or turning off a light, right? That's the actuator side. And if you think of those two groupings, you also have two different levels of security to worry about, if you will. Like, so one of the big things everyone talks about in this space is, oh, what about security? What happens if someone hacks my home? Well, I don't have any of this stuff running in my home. I have it all running here right now. So I'm not worried about the home hacking situation. But if you are running a manufacturing plant or distribution solution, a hospital, whatever it might be, you do have to think in terms of how do you secure these components. And in the case of sensing, right, I would argue that there's actually a different level of security than if you're actuating. Right? If you're just reading data and someone happens to hack the data and steal it, well, maybe the loss of the data is important to you. It could be. Or worse, maybe if they fake the data and put the fake data stream into your network, that could be more problematic. So you probably want a little bit of logic that basically looks for anomalies. Did the data stream stop and then restart? And did we notice, based on historical trend analysis, that it's moving one way or another? Right? I might look at it like that. You certainly can put different levels of security out here. Most of these things that I have don't specifically support any level of security, like an Arduino doesn't really have much. But you can buy additional chips to give you unique identification, give you some form of certificate-based authentication, some form of encryption as an example. But on the actuation side, you really got to think about that pretty hard, right? If I can turn off the light, maybe no big deal. I can play with my neighbors, turn off the lights, kind of thing. But if it's a traffic light, it's a problem. If it's a traffic light for a railroad switch, it's a big problem. So, that's how I think of security. You have to decide where the possible areas of damage are to the world at large, and then decide how much you have to secure that thing. Okay? The next tier of the architecture, though, is once you have your sensors and actuators, you typically have this concept of what's called a gateway. This is the bridge, if you will, to get to the cloud. And the gateway is mostly some form of transport protocol broker or router or translator. Because this world often is a serial connection, and if you're dealing with old manufacturing technology, it's some form of electrical current over a wire, right, in various forms. But also what we're seeing now is like Texas Instruments, which I really love. They're doing tons of these sensor packages now, and they're either 802.15.4 or Bluetooth, as an example. So you have these things that don't really have an IP address, right? Bluetooth doesn't have an IP address. It can't connect directly to the cloud. So it has to send its traffic through an intermediary to get to the cloud. So you're going to see a lot of that in this future world where there's some sort of intermediary. And the reason I say that is think about all the Fitbits that you might have. They work through your phone. They don't go direct to cloud. They send their data to the phone, which sends it to the cloud. And that's how they work. So the smartphone is a very common gateway in consumer-based goods. In the case of your home, right, if you have a Nest thermostat, Google intends to make that the home gateway. And then I'm sure all the router manufacturers are going to basically put all this intelligence in the routers, and that'll be the home gateway. So we're going to see an explosion in this space within the consumer space, but it is popular as far as architecture goes in the manufacturing world, industrial world. So some form of translation, if you will, happens here. Perhaps you're doing some form of real-time decision-making even, right? I don't necessarily want to send the data. If there's a fire, if there's a fire burning, I don't want to send that data all the way over here to make a decision over here to then necessarily fire off the extinguishers over here, right? So you might have some sort of in-the-field intelligence as well. But once you get beyond this, you have this ingestion area where you have to collect all the data. This has to be pretty high volume. I remember working with briefly talking to a group of people in Atlanta that basically were doing smart meters. They have about 1 million smart meters out there, and I don't know where they were deployed, they didn't actually say. But the smart meters actually returned a data packet about once a second, which was a lot of volume. But they had 1 million transactions per second they had to deal with. That's a lot, right? And so, and they actually figured it out. They actually took a whole bunch of ESBs and set up 50 different servers out in front of the database, if you will, that all they did was just receive the data and then queue it in memory until the database could accept it and persist it to disk. So this concept of a big ingestion engine has also been out there for a while. And in our case, we would do it through a message broker. As an example, you can use a message broker for this sort of thing. But there's also people using time series databases as well. A database optimized for time-stamped data and input, right? This is optimized for input, is the way to think of it. And then you have some form of analytics engine, whether it be real-time or batch. This is your Hadoop world. This is your Apache Spark. This is your Apache Storm, as an example. We use Spark for our little demo application. And basically, it's doing some form of data analysis and making decisions about that and giving you more actionable information. So, if you think of it from the perspective of where we've normally lived as enterprise developers, this can be fairly new, right? If you didn't work in the manufacturing world, as an example. This is kind of a new thing to think about. Oh, massive volume of streaming data. Okay, I've got to think about that a little bit. But I looked at WebSockets a while back. I know what WebSockets do. Okay, that kind of same kind of world there, right? Analytics. Most big organizations these days already have an analytics solution. They've already adopted Hadoop, it seems like. So maybe you already have something in place. You just have to think about the streaming aspects versus the batch aspects. And that's where something like I said, Spark comes in, as an example. But then it's off into our world, right? Our traditional world of building web-based systems, character user interfaces, batch applications, highly transactional applications, whether it be through .NET or Node.js or Java or PHP or whatever it is you've built. Right? Then it's over in your world as an example, with dashboards and workflows and any kind of things you want to have there. So one thing I want to encourage you to think about, though, is all that stuff more or less lives at the data center. You do have 3 different types of edge architectures, as I like to think of it. Right? There's a ton of startups right now trying to use some form of direct sensor, direct actuator connectivity to the cloud. Right? So that's like my particle. That's my particle here. Let's see. This guy. Right, so that's my particle photon. I've got, and I also have the Spark Core, the original version there. All right, so those guys basically are MCUs directly connected to the cloud through a Wi-Fi chip. That's actually the Wi-Fi chip on top here, that silver thing. The actual MCU, the brain, is actually underneath. They put it on the underside. So they actually have chips on the other side and chips on top. It's kind of cool. And so that's an example of a direct connection. And they're not behaving well because my network connection is not behaving well. So since they can't communicate with the cloud, they don't behave very well, as an example. But that's what I'm referring to here in this slide here. Let's see. Is this direct connection to the cloud. So you can easily use this chip. And you can see this one I've got wired up with all kinds of sensors and craziness and whatnot. And I've done all sorts of actuators off of it as well. It's pretty easy to do all that sort of thing. You know, I have different types of touch sensitivity here, pressure sensitivity, temperature, humidity, light sensitivity, accelerometer, things like that. You know, is it moving? An accelerometer might be important. Is it vibrating? Vibrating could be bad for our business, right? We don't want vibrating. We don't want heat. We don't want cold. Think about it, all the products that you might sell and things like that, right? We actually, let's say we ship produce around the world. We don't like heat. I worked briefly with the guys down in the middle part of Florida moving oranges. You know, they didn't like heat. And they live there in Florida. So they have to be, you know, they have to be really smart about heat. And monitoring heat is important to them. They also were very keen on weight. They were very, because that's how they paid everybody, by weight. So in that case, it was a system that weighed trucks as they drove across a set of plates in the ground. And so I worked on a system briefly that had to deal with the weights, you know, the weighing of trucks. You know, came in empty, left full kind of thing, and that's kind of how people got paid. But you know, you also, so in addition to direct Wi-Fi, you also have this concept of like a Bluetooth environment. This is your Fitbit kind of thing, or all the stuff that people are doing for wearables. But you might also have this concept of a mesh network, and this is where 802.15.4 comes in. And so I actually don't have any demonstrations of this. I'm still working on these at home. I'll get those working. The idea of a mesh network means you can route around problems, right? These are direct connections. And if there's something really interfering with that connection, especially a wireless connection, like some sort of big DC motor that's producing a lot of RF or a lot of electromagnetic interference, right? It might actually cause traffic problems. And or if in the case, our case with a big conference center, when you got too many people in the room running their laptops and phones, you shut down the Wi-Fi basically, ground it out entirely. And so I'm actually looking at this kind of technology to deal with that specific problem. I don't want my sensors to go down in a big conference center any longer. So I think I can solve that problem at 802.15.4. It's still 2.4 gigahertz, so it's still technically in the same band, but it is at least a different architecture to move the data over the wire, or wireless in this case. Couple things, and we'll get to the demos, I think. Is the pizza arrived yet?
It's here, yeah, and I've been sitting over here trying to think, do I come up now? Do I come up now? Do I come up now?
Oh.
So we'll just wait till the demo.
Okay, well, let's just run a couple more slides, and then we'll stop and then we'll do the demos.
All right.
Because then people want to come back. Already they're bored, I can tell. Okay. I threw these in here because, again, I like looking at things from a historical perspective. And Computer World, actually, all the archives are up in Google Books. I don't know if you know about Google Books. They've archived Computer World. So I've actually gone back through a couple decades with the Computer World, just looking at stuff going. Because one of the things you'll have this insight at some point, this epiphany as a technologist. You know, you're going to go, wait a second, did we see this once already? Yeah. Have we heard this before?
Embedded systems before.
Yeah. And in this case, I wanted to think about the challenges IoT faces right now, which is all these different standards, all these different challenges with different groups trying to say, okay, we've got the Thread protocol, we've got IoTivity, we've got, there's like 15 different players, all different consortiums of different vendors trying to come up with their own protocol standard. There's CoAP and MQTT and all kinds of craziness, right? And I'll have a slide that is an example of that. So this is where we are right now is much like in the early 90s. So in the early 90s, for those folks who have been in the industry long enough, you might have remembered TCP/IP wasn't the winner always. Wi-Fi was not always the winner. I was a network administrator for a period of time. I ran the network system for the little group that we had, right? Some people might remember network. Some people might remember things like Banyan Vines, right? Or SNA. NetBIOS, all kinds of different physical layouts, like different token ring and things like that. As well as different network stacks, IPX, SPX, etc. So that was a very different world, right? we had people who literally ran around and figured out, oh, if I connect these two wires this way and this way, then these things talk for a little while, and then they break, but they'll talk for a little while. And that's the world we're in right now with this IoT thing. There's a lot of competing standards, a lot of competing vendors. There's not actually one winner yet. And so I make that point because even like in the SQL days, SQL wasn't always the winner. We're still mostly using SQL 92. I think 92 is the year. We're mostly still using SQL 92, but prior to that, everybody's SQL was different. It was unique. I worked on 4 different databases for a period of time. All the query language, all the things you did for, essentially what's create, insert, update, delete now, or insert, update, delete, is different, was different. So we're kind of at that moment, and that's why I put this picture up here, because there's all these different standards that are happening in the space, so you kind of have to decide which of these things I want to pay attention to, which of them are interesting to me. And these are decisions you have to make as you're designing your system. And it can be pretty crazy. And I've tried a bunch of these things, but I intend to try more. Some of them you'll like, some of them you'll hate. But what we're seeing now is a lot of people very interested in REST. Okay, because like this little guy here, again, this little chip here, it basically is using CoAP. Essentially, it's a REST-like protocol over TCP/IP because it has a Wi-Fi connection. But because there's a Wi-Fi connection, it doesn't run well on a battery. Wi-Fi burns too much battery, right? You don't typically run Wi-Fi over a battery, but you can run Bluetooth over a battery. So you have to make those kind of decisions. Am I running on a battery, not on a battery? Is it wireless or wired? Is it in the field and has to be ruggedized? Or is it in a nice, clean environment where it won't get stepped on or destroyed? You have to make all these kind of decisions associated with that. And you might decide to use different technologies based on what you have to do there. And that's part of the design cycle that you have to go through. And that's why I say it's good to make friends with embedded engineers, electrical engineers, folks who've kind of specialized in these areas and have thought about this over the years, as an example. But this one is pretty cool because you literally, if I had it working, I'd be able to show you, you can curl lint, right? You guys used the curl command before, right? Anywhere this is in the globe, and it basically has sensors, like all these sensors tied to it, or all these, if I have robotics and stuff tied to it, you can send a curl command across the globe. So basically an HTTP hit hits the cloud, at the Particle IO cloud, finds the thing running out there on the global network, and tells it what to do. And more importantly, you can actually tell, basically any of the sensors that you have set up on it, you can actually curl it's the sensor data. All the sensor data can be exposed as properties off this guy. So it's kind of crazy if you think about it. All its functions can be exposed and all its properties can be exposed, and you can just interact with it from anywhere else on the planet. So it's incredibly powerful. But with great power comes great responsibility. So I just kind of mentioned all that here. This is the world we're living in right now. We're going to show you some of these things in a second, but keep in mind there's like 2 halves of this equation. Microcontrollers, you're living in a C++ land, right, with all these sorts of different types of Arduinos and different types of like electric imp, LightBlue Bean. I have a couple of those. I like those guys a lot. The Spark IO, now Particle IO, they changed names. So a lot of these things kind of behave about the same, right? You write whatever is appropriate code for that device. Typically in C, you're in the C world over here, right? This is the Arduino world. That's how I like to think of the microcontroller world. But now there's an explosion of embedded Linuxes out there, as an example. An absolute explosion of embedded Linuxes. I actually have the Edison here. I got the Raspberry Pis, obviously. I got the BeagleBone 1 Black, but I left them at home. It's not as interesting since the new Pi 2 came out. Pi 2 kind of blew it away. Minnow board, I decided not to buy one. It's kind of expensive at $145, but if you really want something a little more high power, you go with the Minnow board. But I did the Kickstarter on Onion Omega. These guys are kind of popping up every month now, right? There's a new startup every couple weeks that's got a new Linux-powered thing, as an example. So we're going to demonstrate several of these things here in a second. Let's, last slide, and then we'll take a break. These are kind of the new skills you'll have to start learning. So whenever I'm learning a new programming environment, right, like let's say JavaScript, I can learn things like asynchronous programming, reactive programming. In the case of Ajaxy on the client side or Node.js on the server side, there's always new techniques and tools like Grunt, or Gulp, right? Bower, right? If you come from that Node.js world, you got to learn new things. You got to learn AngularJS. You got to learn AngularJS 2.0 because it's fundamentally different than 1.0, right? You got to learn React. You might have been a Flex programmer back in the day. So we as programmers, software people, have always had to learn new things. And all I'm suggesting now is let's learn some of these other things. It's actually quite cool. Boy Scouts are doing it. Girl Scouts are doing it. Surely we can as professionals, right? But breadboarding, and this is sitting on a breadboard here. It's just all this thing with all the holes in it. That's the breadboard, as an example. Soldering, I actually just started soldering January of this year. It's actually quite fun when you actually put stuff together. And I've not injured myself, so that was the thing surprising. I've not shocked myself. I've not burnt myself. I did melt something down by accident, but it was all fine.
Don't breathe the fumes.
Don't breathe the fumes. You got to learn about these electronic concepts like volts and amps and watts and distinctions there, and how to deal with resistance and things like that. You want to talk about communication protocols at this level, at that microcontroller embedded level, right? Serial connection, I2C. UART, things like that, SPI. Those are the communication models that the different subsystems will work to communicate with each other. This is well before they get out to the Wi-Fi, Bluetooth LAN, right? This is how the one accelerometer will communicate with your microcontroller as an example. It'll send its data over one of these protocols here, or communication mechanisms. You'll learn about resistors, capacitors, inductors, transistors. And then really you want to learn all about the sensors is how I think of it. I want to know what are all the things I can do. I'm like, this is CO2 sensor. I actually have this heart sensor here, the pulse sensor here. Yeah, I want to know if the thing has a pulse. Think about it. I'm a big machine. I didn't know the human operator is in the right spot physically, and they're alive. You've seen that in all the movies, right? They take the eyeball out of the guy, they put the eyeball up the thing, and it still works and unlocks the door. It shouldn't work. That eyeball is cold, right? This is also like a little EKG set of sensors, so I want to look at the electronic heart rhythms, things like that, pressure sensors, things of that nature. So, look at that inventory. I just go to SparkFun and look in their sensor catalog. They've got a million of these things. You think about what you might want to know about the physical world. So let's take the break, and then I got to make sure these demos are running, and then we'll show you all these components we have here on the table.
All right, so I bought a bunch of pizza. It's out here. Can we eat in here? Yeah, okay.
This is one of the images for this garage building. It's a remote control garage building. This company, I thought of it since you asked about the storage. I don't know if this has storage on board, but I think it sends all of its data up to the particle cloud, so you can get to it from the cloud.
I think for me, the part that's still
This is actually demonstration.
Yeah, let me see if I can get these guys to the left.
So, okay. Very cool. And you're playing with the Bluetooth because they've got a version of Bluetooth, they've got a version of Wi-Fi.
I basically want to, I want to be able to call this guy when I left the room and came up like,
Well, if you look into that Raspberry Pi, if you look into MQTT, they have things that you should be able to and use the Wi-Fi on the Raspberry Pi. It's hard to tell you the classes. You can even use stick. You can use like so I don't even use my computer. Those both have
That's actually a heavy industrial manufacturing.
They change it.
Every sole certified exam well, they want it to show, your chart where they show all the people. Then they show like a little red line when the guy goes to get after the CEO. I guess that was kind of.
Pick back up. Alright, so
Yeah.
we're gonna mess up this entire time.
Go to
Hey, so you buy all this stuff out of pocket, or are you sponsored by someone?
I've been written about
So you're
some-
Yeah, you mentioned that that dealt with the I think
Over how long?
SmartCon.
Yes.
Do you need to have
It's about 30
We have a
So
couple of
it's really not that expensive.
we don't have it yet.
Yeah.
And once you get into the.
At the hackathon I mentioned, that's at the end of this month.
People will tell you, okay,
We're gonna have a few connects there and also the data served
So it's dollars, about, $8 to $10.
So a bunch of people can
So this
access
is
it.
Do you have like plans to sell off ideas, or are you just fully experimenting?
There's two ways to do that. One easier and one harder.
I've got some people that.
So we do have to do that.
So the one solution for if you share it helps the data connect doing it visualization.
Or is that only something like trying to pull it, it's not in like.
I think there's a certain technique or is this
That's just the only slightly special thing.
So you have to get like your seeking.
A couple people that interested haven't had the shape.
I brought up
came in.
my to stand while you had your stuff here. And I'm
think
assuming
some
you don't
people
have
wind up
one
with
just
just
that
that
size. So I was thinking of
That was USB.
Yeah, that's funny digital.
Yeah, and I think this one connects right into the Xbox. And it gives it power. But if you want to have USB, I guess it needs like a 5 this. And
Power and this to go.
yeah, this one just came with it, but a couple people haven't had it. But this is like $8.
Yeah, makes sense.
The software, was that, yeah.
Yeah.
You heard of the
Yeah, it was all
Edison
JavaScript.
Yeah.
That's
And,
pretty good.
You had that.
Easiest way to get through
Yeah,
is
you had that.
Wi-Fi, you know. Too much of
They
that.
might be interested in
But the Edison is just.
Yeah.
I don't know. I've done some JavaScript, but I haven't done any WebGL.
Oh, yeah, you don't have to have WebGL at all.
It was a while ago, a long time when I got it.
There's a really nice website called 3JS. That takes all the really confusing hard stuff from GL.
Just like a real, just like a
So it's more like, it's not like creating vertices, triangles, and attaching it to like.
Yeah, so I was gonna try. Yeah, right.
So it's really easy to just say, okay, we take this one and then you can change that for 600 and see what happens. And that's
Well,
like,
and I can
Do what one of them.
we haven't talked about it.
Like starting the two of them, you do a 3D image, you'd have to have stuff for a way to print a 3D image, but
Yeah,
but
we talked about it. We haven't actually made it happen yet. It is a lot of data. It's about 17 megabytes or something. As far as going from the server to the client. You're right. At the hackathon, I think we have like 15 people connecting. Trying to push out 17 megabytes per second to all of them. So if you're working on it, I'd like to
okay, when it is, does it have to connect just before out there?
Oh, no.
So if you had your own router.
Yeah. Oh, yeah, I was thinking about it.
Basically,
The website is handle that.
and now there's some companies like Cypress
And then the more pressing reason that we haven't distributed
got an ARM
is
processor like Pod and Arduino.
figuring out how to combine those two depth arrays in a way that makes sense.
Also,
Do you want to do that?
Well, you'd have to, the sensors have to know where they are right switching to each other. So, I mean, if you preset this was going to be
15 meters. Yeah, very cool. The world is.
I'm gonna give away some T-shirts.
I know
Tesla?
people that were trying.
I do not. Tesla 1 was translated to JavaScript as well. And so that was a little off-putting, I thought. And then Tesla 2 hasn't shipped yet. I can't remember if I ordered it or not. I have pre-orders in for so many gadgets.
When you put up your big slide, I kind of laugh. There's only 5 on there that I don't have at least one of. And like the PaaS, I've got 4 versions of the Pi. The Arduinos, I've got 6 versions of the Arduinos.
I've got, you know, like the Pro Minis.
Like I buy those by the half dozen and 3
Yeah.
dozen and 5 whole.
Right, I have
But it didn't
got some of them at home.
like it didn't go more.
But yeah, I was
Like,
promoting
ended up
the 25 the 2650.
Like,
Yes, it's 50, this is the older one.
Yeah, well, I've got this one. I haven't ordered those yet.
Yeah.
LCD for it too.
I have
So do you have a card?
So that's a right in, they give you an extra jack.
That's not an LCD, that is the low power micro thing that you can micro power.
Yeah, it's totally like this, but they call it an LCD.
Well, it's different technology.
But it just puts right in.
So it's basically 2 times the booster board.
I'm gonna give away some T-shirts. We got 4.
I used to be an IBMer and
Yeah, I'll run some demos of it.
Is Mark here? Mark Yarborough. No.
week or two, you hear about IBM wanting to hire.
John.
Cole.
So IBM's a great company. Sure. I mean, yeah, I'm starting my business on my own dime. You know.
No, I'm saying you IBM, you were there for 5 years, they still always give you that.
Well, in retirement, changed from something, they used to have retirement where they would pay you monthly. And they gave everybody cash balance left. So it's an IRA, basically.
Chris Hemp?
Taking it on the road, you would move from company to company. Elected 2000, I didn't.
And the Wi-Fi shield.
MR.
You could buy the Wi-Fi shield for the.
He's not, no.
So,
just use the electric.
Yeah, I get it.
I can give it to
Super hard.
you know, there's,
Huh?
I can give it to Guy
What, you wanna try again?
Nah, he's not here. Who's he? Garrett? No?
He's not really talking about the really good stuff.
Was it? All right.
Talking about H1B.
Excel or
You know, and he's gotten to Jeff's sessions. And there's some people are starting to say, hey, wait a minute, these H1B visas are, we're just letting companies bring in anything. You know,
You have small?
No.
we're letting companies bring in to the United States all of the low and.
These are all the people that RSVP'd, and
No, I know,
We're doing what they call labor arbitrage, and everybody who was high in salary is going down, and everybody's low in salary is going up. And yes, it's a good thing for the world, but it's not too good for us.
No, I know, that's what you're talking about.
So the
Oh,
only thing you can do is start your own business now.
Chris,
That's about the only option.
Yeah.
I just read.
Kate, Philip J. So we're back at the beginning.
What about me? I'm not on there?
You're not on there. Well,
I always think it is.
let's try it again. It pulls like the first 30 people.
Oh, that's not fair.
Well, a random 30 people. But I wasn't supposed to go all the way through the cycle because if you RSVP, you're supposed to be here because that's how we know how much pizza. Burr, what is going on here?
I don't think it's in there. There's a.
They're definitely right on ways to do things.
Well, did you make an announcement that maybe people don't know why you're flashing the pictures? What makes you think you're doing something?
Oh.
Hey.
But people are paying attention.
But, I mean,
If you see your name, let me know. Because we had like 150 people RSVP for this, and obviously there's not 150 people here. Oh, there we go. All right, finally you made it. Are you ready?
Yeah.
The longest t-shirt giveaway.
Sorry. What? So, quick question. What do you guys think of the new logo? It's a lot better than what it used to be. I don't know if you guys saw the old one, but the old one was terrible.
Did you have a
No
designer?
offense to whoever made it, but huh?
Can you have a designer?
No.
Turn off the screen with the flashing panel.
What?
Flashing.
The Apple screen. No, I have no idea.
All right, I should pick you back up again, right?
Is it always flashing? Reboot.
Just at the last 10 minutes.
Oh no. How annoying is that? You know, there's
Wait a minute.
a whole other section down there with monitors that actually work. Oh my God.
All right, let's, we don't want to keep you guys here tonight, so let's try to run through a bunch of these things that I have here on the table. And you're welcome to come look at them afterwards if you like. And if it seems like I didn't make a lot of sense when I was doing all those slides, it's because I messed all this up right before we started. So hopefully I just fixed it all while you guys were getting pizza. And I'll tell you right now, the magic, it's actually hard to present these things because you got to carry them about and they tend to break and they got to go to airports and things like that. And the magic I figured out is this guy right here. This is basically a Wi-Fi router. So I've set them up to look for this router. You know what I mean? Otherwise, you got to get into each one, reconfigure it, and it's a pain in the butt, and you got to get a new IP address and everything else, right? And so, so the router bridges to the internet. In this case, I actually had some problems with it, so I thought I'd reset it, which basically tanked it, and then I had to get it back to life, and then now I have to go back and reset every one of these devices anyway. So we'll see how the connectivity works. But I'm going to show you this one right here. This guy is not connected right now. So it has a little LCD. It's based at the NXP 1768 right here. Okay. He's actually a microcontroller that's actually physically rather large. It's actually very powerful though. And it's a microcontroller specifically writes C++ code for, or C code for. It uses the embed platform, which you go to embed.org and you can sign up there. And the idea for this is ARM, so ARM is sponsoring this project. And their goal is to basically provide a common programming SDK for all the microcontrollers of the world. Because right now, every microcontroller you buy from every different vendor comes with its own unique SDK. They're all basically C or similar, but they're mostly C. But the SDKs can cost $3,000 per developer seat or more. And they're all programmed slightly different. And so the ARM folks, the funny part is they're all using ARM designs for their chips, right? But so ARM said, well, why don't we just try to make a common SDK that's freely available to all the embedded programmers in the world? And embed.org, you can sign up there, and you can also write your code right in the browser. And then when you actually hit save and compile, it'll download the code binary file, and then you just drag and drop it over your USB connection to the device. And so this one's already done, so it's already programmed. And with a microcontroller, all you do is give it power, and then it starts running its project, right? So I'm going to turn the battery on here, and it's got a little accelerometer down here, a little LCD, and it's got my little ball down here, flashing there. Oh, you can't see it. Okay, there we go. And it's not behaving correctly. So here's how you fix it. You unplug it, and plug it back in to reboot it. And there's actually a reset button on this one. But let's see if that sorts it out better. It might be that my battery is kind of going kind of dead. Oh, so it's not behaving that well. But basically, all this is a little accelerometer. It's like a little game, right? It just moves the ball around the screen. You can move it around. It's not behaving that well, but since it's on a battery, you guys can play with it. And
do you want to try a different battery?
No.
Okay.
But feel free to pass that around and check that out. So that's the embed platform. Again, it's a C++ world. Oh, cool. I'll show you another one here. This let's show you this one. Okay. So this is the LightBlue Bean. I have one. Oh, that's a pretty screen. There we go. And so this is, I actually set this one up myself. So here it is. So here's the LightBlue Bean. It's about the size of your thumb. This one I solder on a little light sensor, a little photoresistor right there. It has a temperature sensor and accelerometer built right in. and it has that big Bluetooth radio on top, right? That's the Bluetooth radio right there, the big blue thing, and the little MCU is that little guy right there. So the brain is smaller than the radio. It's pretty common. That's pretty normal. And it has a little coin cell battery on the back. So that guy right there will operate off its battery for a long period of time because it actually has a very aggressive sleep cycle. It's very clever. You can set it to only wake up when you communicate with it. So only when you just say, hey, sensor, I call him sensor, right? Sense. I need to talk to you. Then it wakes up and starts running its code. And what it does in its code, it took me a little while to figure out. What it does in the code, oh, there it is. I lost the icon. All it's really doing is if you look here, you can see there's a loop, so a void loop. And it's basically grabbing the data, the readings, from the different sensors on this guy, and it's storing in little buffers and sending what's called Bluetooth scratch data. So basically, and you can't do a lot with some of these things, right? They're fairly simple devices. This essentially is Arduino with Bluetooth, right? So it's the same chip as the Arduino as an example. And you basically are writing code that says, okay, grab sensor data, load in scratch data, and the cool thing about it is your Node.js app can now grab that data, right? So basically, you wake it up with the Bluetooth signal, say, sense what you need to sense, sample what you want to sample, give me that data, go back to sleep. It's kind of the architecture you'll have on it. So I'll set that down here, and I'll show you that as an example. So I also have my, let's see, which one of these guys did I use here? Okay, so this is my Edison #1. So I'm SSH to Edison 1, right? So that's an SSH connection to this guy. Right, so he's right here. So that is a full Linux server. It's the green part, by the way. The red part is just the battery. Right? So the green part, which is almost paper thin, has a Wi-Fi radio and a Bluetooth radio, and it wants to turn over because it's so lightweight that even the cable can make it flip over. But that's basically the RF shield right there on top, and that's the antenna right there. That little white thing is the antenna. And it plugs right into my little battery pack. You can see the silver battery, lithium-ion battery, and then the red part is from SparkFun. That's the battery connector. But really, think about it. It's a Linux server on something the size of 2 postage stamps and not much thicker. It's kind of crazy. And I'm SSH'd into him right now. So let's see if we can, he's going to turn over, but ignore him. But watch the LightBlue Bean. I guess I need to make this where you can see it. So watch the LightBlue Bean. I'm SSH'd in. Hopefully you can see it. What was it? So I'm going to basically run the node command. So it's going to do the polar. It's going to pull for the temp off that guy. And when it makes its connection, it actually turns on a little green LED on it. Let's see if it will connect for me here. Oh, there it goes. So there's the green LED. And now it's woke it up via the Bluetooth radio. And now it says, now give me your temperature. Give me your temperature. Give me your temperature. And so if I put my hand over here, we should see the temperature go up. There it goes. 30 degrees. This is Celsius, by the way. You can convert it to Fahrenheit. I just left it in its default setting. All right, so it's sensing. So it's now pulling that data from the Edison, right? And it's sending it out over MQTT. So it's Bluetooth connectivity to the LightBlue Bean, which is my distributed sensor. MQTT data coming over Wi-Fi into my local message broker. Okay, and I'll show you one other trick, and this is also all JavaScript. I'm then sending it all out in real time to my graph here. Right, so this is D3.js. It's actually a special graphing library, JavaScript library for D3.js for time series data right here. And so again, let me see if I can heat it up again, see if you can see it move. Not much, right? You saw it go up to 30 there. So not much. But that's what that guy's doing. Okay? So that's the LightBlue Bean and the Linux box on together. So, and they're battery. So I'll pass these around. It'll eventually lose its connection as it gets too far from my router. But you know, that's your whole setup right there. Their whole IoT solution hold in the palm of your hand. All right, so let's show you a couple more things. We'll let that guy keep running. All right, so this is my second Edison. I'll show you that one. So this one actually doesn't have a battery, and it uses the same Wi-Fi. This red board again is just so I can provide power to it. But again, by default, you see how thin that guy is. The guy on top there, the green part. Okay, so that's Edison, and he's going to communicate with a TI SensorTag, and I'm going to use this one right here. Okay, this guy is an MCU also. It's not a Linux machine. You can't SSH into it. It's just like the LightBlue Bean. But this sensor package is pretty awesome. It's got It's got internal temperature, ambient temperature, IR temperature, so internal and external temperature, right? So you can strap it to someone's head and figure out what temperature they have. It has, this one also has an accelerometer, a magnetometer, temp, and it also has humidity, and a barometer, if I remember correctly. And so, if I've done this correctly, let me run, again, this is just a Node app. Node, and I gotta hit the button to wake it up, because that's how you wake it up. It's not, I haven't figured out how to wake it up based on a radio communication. There probably is a feature, but LightBlue Bean, I spent a lot of time on figuring that out. So there's its temperature data coming in. And let me go back to my browser. So there it is streaming in. So let me heat it up with my hands. There we go, spikes the temperature way up. And put it back on the cold table, drop the temperature. So this is real-time sensor data, right? So from the Edison, let me see if I can get this guy right here. Right, so the Edison, this guy right here, to that SensorTag, right? So the Linux server is smaller than the sensor, isn't that great? So Bluetooth streaming the data to this guy, right? So this is Bluetooth from here to here, Wi-Fi and MQTT off this guy using Node.js out to my message broker, and from the message broker, again using MQTT over WebSockets directly into the Chrome browser here, drawing this in real time. This is not a lot of code. Where's my right, so this is the graphing technology. You can see you're doing a connect or MQTT, you're doing a subscribe, and I have the 4 different channels there set up for subscribing. And then basically the rest of this code is how you draw the graph for this MG data graph technology. And on the server side of this equation, we'll just control C that. Let's do a cat temp 2541. I guess I should have let it scroll a little better, but you can kind of see it's pretty straightforward there. And basically, it's require MQTT. Also, there's a SensorTag NPM already out there. That's what I'm using. It's based on Noble. So the same gentleman wrote the Noble package, NPM Noble package, and basically that's what speaks Bluetooth to things. So Noble is N-O-B-L-E, get it? Bluetooth Low Energy. So basically, it's the bridge between any Bluetooth Low Energy device, and then SensorTag kind of sits on top of that and gives you access to its different sensors. Then I do a client connection using MQTT NPM. This is one of those isomorphic NPMs, right? You've heard that fancy term in the Node.js world. So it works server side and client side. You use Browserify on it to make it work client side. So in this case, this is the server side of that equation. I make the connection to my message broker running on my laptop, right? And then I do my discovery, and standard Node stuff here for discovery, it's kind of the callback upon callback, right? And then you can see it's doing a publish to a certain topic name and with the data that it found. It's very straightforward. Now, it takes a while to figure out, but I put all this on GitHub and whatnot, and if you just email me, I can show you how to do it. It took me a while to figure out, but now it's pretty easy if you think about it. And so that's that one. Let me show you another example of this. Okay, that's my Edison's. But let me look at the Raspberry Pi here. Yeah, so this is Raspberry Pi. So I like the Raspberry Pis. How can you not love the Raspberry Pi? So this is my Raspberry Pi right here. You can see him kind of sitting over here. Just going to move stuff out of the way. And I can move the camera. I guess I can move it. All right. So there's my Raspberry Pi. And he's got all kinds of crazies hanging off of him, right? He's got a motion detector there. We use this as an example at Red Hat Summit. We actually showed, we had 100-some people come in for a workshop. We showed them how to do motion sensing. I can turn an LED on and off. I can sense for light as well. So there's my little light sensor, the little guy right there. It's kind of hard to see. But this little black guy right here, which is almost impossible to see on the camera, is another temperature sensor. All right, so I can interact with a temperature sensor. Oh, and actually I can interact with another SensorTag. But since we already showed you the temperature sensor, let's find something more interesting. TI, SensorTag, node, and let's do this. Let's do a meter. And so this guy, I'm going to hit the button to wake him up. Again, a lot of these battery-operated devices have very aggressive sleep cycles, but you'll see it's going to pull the light data from it. So let it get going there. So it's a light sensor. My wife is particularly interested in this because she wants to know where her garden gets full sun. Seriously, she's told me, you gotta make that work for my garden. Oh, it's working slow, come on.
Does she sound like that too?
Almost. Wow, okay. This was working. We'll let it sit there and see if it'll connect. But if you notice, I have several things there, the accelerometer, barometer, Actually, let's try something else. Oh, I may know what the problem is too. So that's not gonna work. Let's see if it'll connect connect to the accelerometer. I have two of them running right now, so sometimes it gets a little confused. That's why I print out the unique identifier. But there's the accelerometer. So if I can move it around, you should see the accelerometer data change. And so we do the magnetometer. And so it's just making that Bluetooth connection from the Raspberry Pi, right, to the actual TI SensorTag. So I really love these TI SensorTags. These guys are really awesome. You can think about all the different things you want to experiment with. It's all in one package. This is $29, and there's actually a variation of it that comes with the, where is it? I had it earlier. There's a variation that comes with a little screen, and you can make a smartwatch out of it. And there's another variation that comes with, you know, they have these variants of the TI SensorTag. So the TI guys have done a really nice job on this package. You know, this is something you really have a lot of fun with. And you can see there's node examples for all sorts of stuff, right? So I guess I should make that a little bit higher. You guys can't see it, right? So, you know, I want to sense light. I want to sense temperature. I want to sense, it even has push button keys on it, as an example. So I want to see the physical change on the device. I've seen people use that as like a presenter kind of thing, you know, change slides. And let's see here. Okay, and this is actually I have one more on the same Raspberry Pi over here. So not focusing that well. Focus. So basically it's grabbing the temperature from this little breadboard on here and this little temperature sensor on the breadboard. And again, it's going through and sending out, should be sending it out into the browser database. So it's that data set coming in at the top there. So you can do a lot with a relatively few lines of code and using Node.js. I try with Python and Node.js is where I tend to work. Obviously, I'm historically a Java person. I should use Java, but I'm having a lot of fun with Node.js as an example. It works so well. And you can run it on incredibly lightweight machines like you see here. These Linux machines are pretty powerful. What else? Oh, let's show you this guy. Yeah, let's show you this one. And let's see if I can get him running. Get that subscriber running there. Okay, so it's basically going to be a listener. And let's move this one kind of out of the way. Get this one over here. So this one's kind of crazy. And we'll see if we can make it work. Okay, make sure it has power. So I actually have, this one's kind of tricky because it has to have, this actually robotic hand requires enough juice that the Raspberry Pi by default cannot drive it. Right, so this is, when you get into the world of electronics, you have to think in terms of, okay, some things are 3.3 volts, some things are 5 volt. You know, the Raspberry Pi is digital only, no analog pins. How do I deal with that scenario? In this case, you know, I learned the hard way that Raspberry Pi didn't have enough power in it to drive the hand, the big servo that's in this hand, and therefore it actually made my laptop reboot because I had it plugged in via USB at the time. So it basically pulled enough power from the Pi through the laptop. It was like the back said, "Sorry, we're rebooting now." It's like, okay. So then I basically had to learn how to wire a proper battery pack. So this is 4 AA batteries that gives it 6 volts. Right, and it basically needed a little bit over 5 volts, and so it's 6 volts, and I have power to it. So these little guys, these are just 2 little servos, and since he's listening, I can just send it messages. I have okay, so let's do this. All right, let's see if this will work. So I'm using again the MQTT JS. Right? So if you notice, he's right here. So I told him to turn to the right. That's, again, I wrote the code for that. You figure out what you want and say, go to the center. There's center. And I was just doing fun stuff. I have other examples out there on YouTube. But maybe this big guy here, I'm going to say open. And say close. And so I actually have some other examples where I was actually measuring the amount of pressure you're putting on some of my pressure sensors and making the hand open appropriately and close appropriately. So you get pretty sophisticated with this if you want. And I wouldn't say MQTT is the way you would want to communicate with a robotic element, but you can, right? And it's just a few lines of JavaScript code. So, you know, I was thinking, let's try that as an example. So that's an example again where now not only do you sense the world, you can touch the world, right? This is the concept of actuators. And I didn't bring all my other stuff with me, but like this is an example of a relay. You basically use a relay, so the relay can accept, let's say, the 5-volt output from the Pi, and it's less than 5 volt on the actual GPIO pins. But you then power this separately, and then it can handle a higher powered device. Okay, it's electromagnetic switch, just like light switch. So basically, you can send a little charge to it and tell it to flip open or off, and therefore you can turn on or off a floor lamp or a gumball machine or anything that's normal, right? Anything you normally plug into a wall, this guy will handle. And this doesn't cost much. And so that's wire bundle here. Normally I wire it in and set it up, but I didn't have time to do all that. An example. So you can do a ton of interacting with the physical world, sensing it or interacting with it, touching it, as an example. Let's see if I can show you one other thing. We'll see how this behaves. I got too many windows because I really was breaking things when we were setting up. I don't remember. Let's see. Oh, my photo is in here. I have my notes that I use probably. Tells me where I put things. So let's see here. This is my particle projects. Oh, I'm actually SSH in. Let's get out. That would help. Okay, particle list. Let's see if these guys actually are on. So remember I was telling you earlier that the microcontroller and the Spark IO or Particle IO device allows you to use curl commands and interact with it. Let's see if it'll respond to me. It's basically trying to hit this guy right here. Get this out right. It's basically trying to hit this guy right here. If I can make it work, that chip. Looks like it's going to take forever, but he should still be running. So let's see if he's still running. And can we connect to the serial connection? Okay, good. So it's still actually running, even though I can't flash it any longer. You can over-the-air flash it, which is pretty cool. So anywhere in the world, wherever it is, once you've made a code change, you can say update that device wherever it is. So it has over-the-air update capability, but it's not acting right now that I've changed my network configuration. You see it says everybody's offline, when in fact it's running. You can see it's running right now. So all he's doing is running the code for his little light sensor. There's all these different sensors on the board. I had to spend a lot of time trying to make the wires pretty, right? But there's an accelerometer. These are different types of pressure sensors. Pressure sensor, that's physical pressure. Touch sensor, temp. But this guy is the light sensor right there. And so it's basically just sending out the data that it's receiving. Okay? It's just pumping out the data that's receiving. And so if I cover it up, it'll say no light. And if I brighten it up, it'll say bright light. And let me just show you, it's very simple logic. And where did I have it? Oh, I actually use Atom a lot for programming for this guy. Because the nice thing about the particle solution, they give you the command line. It's an NPM command line, right? So they're assuming you're kind of a Node.js person to some degree. And you use their node-based command line, and they have Node.js-based servers, and you can actually, their source code is all open. So they're an open source company. You can get their Node.js servers from the cloud as well. But the actual firmware on the device is written in C, right? So just like Arduino, right? It's written in C. And you can see here, I'm basically looking at A1, which is analog 1, on the actual pin for analog 1. And I'm simply just pulling the data from it, right? It's doing an analog read. It's grabbing the data. And if it falls above a certain value, it's bright light. If it falls below a certain value, it's low light. That's all. So if I cover it up, low light. Right? If I use my flashlight, bright light. Cool. Simple logic. But this is what it looks like to program in Arduino land, even though this is not necessarily an Arduino. It's an Arduino that's Wi-Fi powered. Just like the LightBlue Bean is an Arduino that's Bluetooth powered. They're both Arduino kind of class machines. And you program them in a similar way. And the cool thing about this is you can use whatever editor you want in particle land, and then you have a command line compiler and a command line flasher. Right? You can basically say, I'll flash the device, but that's not working for me right now. I'll just show that to you. Very straightforward stuff. You can see I've got tons of examples of MQTT and using the robotic hand. I spent a lot of time on this one. I was really geeking out on this about 9 months ago. Had a lot of fun with that. A couple other things I'll show you though. Again, so think of him as he's the Wi-Fi enabled Arduino. LightBlue Bean, which is being passed around, is the Bluetooth-enabled Arduino. This, when I say Arduino, by the way, I guess I assumed you knew what that was, but this is the Arduino. This is what started it all, if you will. So this is an open source piece of hardware, and this has been the miracle that's made all this happen. So I'm going to give all the credit to these 4 or 5 guys over in Italy who basically they were teaching classes. They wanted a cheaper solution to teach classes and teach firmware, embedded programming, embedded engineering. So they came up with their own design for their own programmable component, right? So it has you can put your different sensors in, right? You just put in your leads right there. You basically use your jumper wires in right there. This is the chip for it. And then you give it power, and then it has a USB connection to go to your laptop, right? So that's how you flash it, is through the USB connection. And the IDE looks like this, right here. So I was using it for my LightBlue Bean, but you can use it to program anything in Arduino land, right? It's the Arduino IDE. And the cool thing is they open sourced all the software and all the hardware. And that was an absolute game changer. So if you think about the nature of open source and the game changers it's been in your world, right? Open source has touched you in dramatic ways. Right? Node.js, if you're a Node.js programmer, you're making all your money off an open source project. Your entire livelihood, your children are going to college because of Node.js, right? And Angular.js, and React, and all these other components that you guys are using on a regular basis. And I don't want to underemphasize this enough. These guys did it with hardware, and it's changing the world. They did it with hardware. And billion-dollar corporations are having to react to this. 5 guys in Italy. So now if you look at these multi-billion-dollar hardware vendors, they're like, oh, we're Arduino compatible too. It's kind of mind-blowing, right? This is what started it all. And because they open sourced the hardware, really creative people built the LightBlue Bean with the Bluetooth radio. The Spark guys built the one with the Wi-Fi. There's the Arduino Pro Mini, right? Look at that guy. Here it is. Arduino. So it's the same thing, just in a different form factor. And in this case, I actually soldered on the pins myself, so I could do the breadboarding with it. This one I just left unadulterated, just because it's so cool and small. But you can't really use it that well in that state. But I just want to show you. And these things are cheap, relatively speaking. This gentleman over here was telling me he buys bagfuls of them whenever he gets a chance. And people do, right? You'll buy 20 at a time or something. Yes, sir.
And there's Electron coming, which in that almost same form factor includes a cellular modem.
Yes, that's a very good point. It is slightly bigger.
With a cheap interface per month, too. So
Yes, they're also MVNO. Yeah, so the Electron, which is the same guys here, they have Wi-Fi today. This is, by the way, this is the old Spark Core, so it's $39. The other one, it's the same thing. It's $19 now for all intents and purposes, the Photon. But you get Electrons, which means they come with a cell SIM card. And they'll give you, in the US, they'll give you a $2 to $3 a month charge to run it. So now you can actually put your sensors on propane tanks that are multi-kilometers away from civilization, or the windmill that runs the horse's pond in the middle of nowhere, or the thing you're tracking weather conditions on the top of the mountain, whatever it might be. And so these guys are, again, using open source, right? They took advantage of the Arduino, they open sourced their own technology, and actually several other vendors now have jumped on their open source bandwagon. There's actually another Bluetooth kit that I've already done on Kickstarter. It's called BlueZ. Or Blues, I should say. It's a Bluetooth version of this one. There's like 3 or 4 others, that are coming out. Not the Onion guys, but another one we talked about in the embedded group, robotic group. But they're all, again, every week on Kickstarter, some news coming. The one I'm really excited about that hasn't shipped yet is called CHIP, C-H-I-P.
$9.
$9. It's basically this Edison, not quite as capable as the Edison, but $9. This is $50. All right. So everybody, the amount of innovation happening in this space is absolutely amazing. I'm trying to think, is that all? I could go on all night showing you different stuff, but we probably don't want to do that. The only thing I would show you is the LightBlue Bean, which I passed around there. Again, you're responsible for, and LightBlue, by the way, now has more of these on Kickstarter. They have a way more powerful version of it. This is the original first generation. But basically, you solder on the components you need. In this case, I have the place where I can put my little jumper cables. I also add the pins on the back for breadboarding with, as an example. So I've soldered on buttons. I've soldered on sensors. There's like just another set for breadboard. And like this one, I have a YouTube video on this one. Because I put on a little button. It's my internet-powered Bluetooth button. I can do anything I want with this button. Seriously. I got to write all code for it, but I had to write the firmware for the button. I had to do a little debouncing, right, which is something we talked about in the tri-embed group or robotics group. I had, so I'd wait for the clicks, and if the click is in the right time frame that I want, the time range, right, I basically drive a little servo, this little servo here. So you see that in my YouTube video, and I use, so you can kind of do anything you want. So touch the physical world, let the physical world touch you. And I think that's all I have to show for tonight. And we're really close on time, but there might be a few questions. It'll be 9 o'clock soon, but do you have any specific questions, or at this point you're going, oh my God, this guy's a moron. He talks too fast. Yeah.
I see you running your own local MQTT server.
Yes.
And have you thought of putting that in the cloud, or do you do any peer-to-peer stuff where you use start and return to cross-communicate with IoT devices?
It's one of these windows here.
Yeah.
Yeah. So I am running it here mostly because I will do this demo with no internet connectivity. So it's critical that I'm able to run things locally. At the same time, I'm working with the OpenShift team. I work for Red Hat. And so with OpenShift team, so we get the broker running properly in the cloud. And we just figured that out like yesterday. I got the code from the guy yesterday, but I didn't have a chance to set that up, obviously.
Are you running the Docker container of
Right.
the
Exactly. It's the Docker container for AMQ in that case. And so this is ActiveMQ, who is our message broker. You've heard of Apache ActiveMQ probably. And that's running the MQTT engine in this case. It also supports Stomp and AMQ, AMQP, and all kinds of other things. And it's literally the broker that's, the sensors are coming into the broker, and the broker is then publishing it back out to the browser. And that's what you saw earlier in the browser. So in this case, the browser is communicating directly with the broker also, over WebSockets in this case. Other questions? Yes, sir.
Having worked in the embedded world quite a long time ago, before it was called IoT and
right.
got all the communication, I know that one of the big gotchas was the RF certification, the emissions stuff.
Yes.
And I know that on some of these I've seen that they certify like these prototyping components that they're already certified, so you don't have to deal with it. But if you get into any custom stuff or anything, then there's that. And I wondered if you've heard anything about that. Seems like it's going to be a bottleneck once we have billions of things like that.
So what just what the gentleman's referring to is if you ship anything with a radio, you have to get it certified, right? It has to be certified.
Or a processor that runs it above a certain speed for emissions.
Well, I mean, yeah, basically they want to know that it's not flooding the airwaves, right, and causing disruptions of cell phones or airplanes coming out of the sky or whatever it might be. Yeah. And so there's actually a team here in Raleigh that's called the Wireless Research Center up in Wake Forest, and I actually met with them recently. They actually have the clean rooms, if you will. When I say clean room, it's not clean room in traditional sense, it's clean room for RF. It's a room, it's like a vault you walk into, and you put your RF device in there, whether it be Bluetooth or Wi-Fi or whatever it is, and then you can actually measure all of the signals it's emitting, and you can also kind of do some testing of it, and that would allow you to know if you're within the appropriate boundaries to get it certified. They don't do certification, you got to take that to another lab, but at least you'll know, and you'll have all the technology you need to test it. But you're right, if you decide, okay, I'm going to build the next coolest widget, gadget, Nest controller, whatever it is, you will have to get certified and to verify that it doesn't emit RF that it's not supposed to. It's in the right frequencies, it's at the right signal strength, all that kind of stuff.
Yeah, it seems to me that the FCC is going to have to do some adapting with this explosion of these.
Well, right now almost everything is limited to 2.4 gigahertz, aside from Wi-Fi, which has a 5 gigahertz range. I don't know of any Bluetooth or any other parties trying to play at 5 gigahertz. All this stuff is 2.4 here. Might have 5 somewhere right here. And there's also the sub-gigahertz, right? There's 700 meg, right? Or 7 to 900 meg. And the nice thing about the sub-gigahertz range is it actually goes further distance. You can't necessarily do like streaming HD video over it, but you can go a lot further distance. Yeah. And there's a lot of people experimenting in that space. They're getting multi-kilometer distances. There's one I saw was, really multi-kilometer distances between the devices, which is pretty cool.
Yeah.
Yes,
so one of the nice things about the vendors who are shipping Bluetooth stacks and other technologies, especially the Bluetooth people, they say when they come in to present to you, our chip is FCC certified. You use the little antenna on there and don't modify it perhaps past a certain amount, you're FCC certified, you can use our license. Yeah, super close. Yeah, saves a lot of time and energy in terms of the market.
But what do you guys think? You guys have been rather quiet. A lot of you have been rather quiet, except for the people on the front line, it seems like. Oh, we got a question way back here. We'll come to you too.
Yeah, one more question. Like, aside, I mean, you have used all of these chips and other stuff, but what would be the best one that you think like more of like, this is the best one over the other? I would use this for this case.
So that's a very fair question. So I would, it depends on where you're coming from, more importantly. So like in the case of like at Red Hat Summit, we decided we got 100 of these kits and we're gonna teach people how to wire them to the real world. And we actually showed motion sensing and temperature sensing, things like that. We went with the Raspberry Pi because most of the people that live in our enterprise world are Linux people. And therefore they could grok the Raspberry Pi. That's something you can SSH into, you can interact with Node.js, Python, Java, C, whatever you want. And we had Python libraries, Java libraries, and Node.js libraries for them to experiment with. So if you're coming from a traditional enterprise background, I'd say Raspberry Pi, because it's a Linux machine that you've probably encountered something like that before. And it works just like Linux works, as an example. So I really love the Raspberry Pi, and I really like my Edisons, though, which are kind of like the next tier up, if you will, smaller form factor, more capability. Not as powerful in the CPU or memory category, but it has more capability kind of out of the box.
What kind of capability does that have over the Raspberry Pi?
By default, it has both Bluetooth and Wi-Fi built in. You don't have to go get additional chips for that. But to finish the answer on that question, though, if you really want to be about embedded programming, however, you'll want to then go to the Arduino and learn that. And the Arduino, and again, the cool thing about the Pi or the Arduino, if you can think of the question and type it into Google, you will find the answer. I'm serious. It is because the amount of people already experimenting with these devices and solving these kinds of problems, like, oh, I'd really love to know how much radon gas is in my room. Somebody's tried to work on that already. We have one gentleman with a tri-embed. His name's Chip, I think. Is that his name? He's done some awesome stuff. He's trying to sense all kinds of environmental conditions. He's actually deploying the devices out in the local state parks to count people movement, because that's actually a big issue in state parks. Are people using the trails, not using the trails? If they've used the trail so many times, we probably need to send someone out to see if the trail needs maintenance, that kind of thing. It's the same thing in airport bathrooms. They're looking at how often is the bathroom used, then send the person out, again, the efficiency kind of thing. But he's done all kinds of stuff with solar, right? And charging batteries from solar, so his device keeps running out in the middle of the what is the park here that he's?
Umstead.
Umstead, yeah, up in the middle of Umstead Park. But that's more the Arduino class world, right? Because very low power consumption. You don't really need full Linux for that use case. It just basically is running your C code in a loop. I mean, that's the microcontroller world. It's like, at least how I think out of my naive view. So you'd pick either path based on where you want to go. Yes, sir.
I might suggest go to Adafruit Learning, and they've got projects in both platforms, and just read them and see which one you feel like you can follow along with better and get your feet wet wherever you feel most comfortable.
Not Adafruit IO, that's a new thing. Yes, but if you're just getting started, I love SparkFun. I spent a ton of money with these guys, and I love Adafruit. So they have
Hit to learn there that they've got all the hand-holding tutorials for about anything that you. SparkFun has great tutorials too, but they're a little more hardcore nerdy.
They're a little more nerdy. I spent some time with the president of SparkFun. He's a super cool guy. I mean, there's a guy. It's just like a guy you've met anywhere, right? He's like, oh yeah, I started this company with a hot plate, literally a hot plate, because you can do surface mount soldering with a hot plate. He heated up the devices and melted the chips onto the PCBs, and that's how he got started. And now he's got a multi-million-dollar company. But just going here to the sensor category on SparkFun as an example, I want voice recognition, accelerometer, temperature, humidity. I want to know about RFID, so I've got RFID stuff that I don't have set up here. I want to deal with pressure. This is force and pressure. Waterproof temperature sensor. I have a friend who's doing a project with that. He wants to know what the temperature of his pond is at different depths, because it actually impacts the fish he has. It's a big pond over in the UK, actually. But just, the same amount of stuff. Proximity sensors. You can use proximity temperature to determine how full or is the door open or closed, or is the bin full or empty? Do we have enough coal or not enough coal? You just have to kind of think about the problems you want to solve, and there's almost something out there for it already. Another question. You had a question.
I did. Originally, when you gave your presentation, you you had those little beacons you're handing out, and you're tracking all those people.
Mhm.
Have you thought about the privacy impact of that sort of that sort of system?
Absolutely. So that's a very good question. So one of the things that we're going to have to get to in this world of IoT is we were going to have to decide what the privacy concerns are that for everybody who produces a thing and fields a thing, whatever the thing is, whether it be the Fitbit or the smartphone or the Bluetooth beacon, is the consumer aware enough of what's happening that they feel comfortable with you collecting that data about them. Like in our case, when we gave the beacon away, we actually told them, this is what we're doing. Come see the demo. You'll see in the demo exactly what we're doing. And we even had a piece of paper just to say, if this worries you in any way, we're not tracking you in the bathrooms. We don't know if you're back in the hotel room. We just know if you're in our sessions. That's all we know. We want to be very upfront about that. But you, the person who's producing the thing and the system, will have to decide exactly how much you disclose about that, and if your consumers will like you or hate you based on what you've now tracked. Yes, sir?
That I was going to throw out there about the tracking of your phone via your Bluetooth MAC address and iOS versus Android, and salted MAC addresses on iOS.
Yeah, you were saying you were scanning for Bluetooth signals.
Yeah, and found everybody's phone.
Yeah, just go on a plane. You can get, there's all these apps for Bluetooth scanning now. Just go on a plane and turn it on and see all the people around you.
But the scary thing is that if you scan someone's phone here 3 weeks from now at another event and you're on Android, you can identify the phone. If you're on iOS, you can't tell.
Right, Android's much richer in this category.
Well, with iOS 8, they started salting the MAC addresses. So they use fake MAC addresses that are disposed and recreated in notation on the iPhones.
That's clever. It definitely helps with privacy concerns.
So you can't track an iPhone user over time or through
the mall.
Yes, through the mall.
But you can't with a Fitbit.
Or pick them up at the mall and then track them at the grocery store and places. But Google is more receptive to collecting information, so they haven't been insulted.
Interesting. I didn't realize they would be go so far as to salt the MAC addresses. That's clever. Yeah, but so from a privacy standpoint, everybody who's producing the stuff and everybody who's purchasing it, and we just all have to be smarter as consumers to know that it is now available and capable. And with great power comes great responsibility. Everyone knows the Spider-Man quote, right?
Has anybody tried to reverse the model? Like the beacons, like the rooms put out beacons, and the phones, like or your phone or your whatever the person.
That's actually the standard model.
No, that actually what we did was actually the weird part. Typically, what the beacon is normally a stationary object.
Yeah.
We actually made it a mobile object.
Okay.
And I had several discussions with people as we were getting ready for this. They're like, "No, beacons sit still." And I'm like, "I want the beacons to move." And we had some real debates with a bunch of people. But literally, the type of beacon is normally stationary. This is my Estimo beacon right here. They make it look like a rubber rock, but it's waterproof and it has a 3-year battery. You put that in your retail store, and this is the device that basically, if you have the app for the retail store and you walk in the store, it'll actually say, "Oh, welcome to our store. Would you like special A, B, or C?" And actually, if you have an iPhone and the Apple Store app, so it's called the Apple, not the App Store, the Apple Store app. So if you have this app installed, let's see what it does here. Hopefully, this is what happens when you do some random demo. Like, oh my God, what is this? All right, so if you have that app installed and you walk into the Apple Store, Creedmoor, Crabtree. It'll say, "Welcome to the Crabtree Valley Apple Store," and it gives you extra features when you walk in. It literally changes the app so it has a barcode scanner. You can walk up and scan the product on the shelf. You can then see more reviews about it. You can say, "Buy it now," using your thumbprint, and walk out with it. I purposely tested this because I wanted to see if it was real. And I'm actually walking out of the store thinking someone's going to come attack me. I paid for it, really. I've done it twice. I did it in San Francisco and the one here just to see if it's for real. Because I read about this. It's like, that's beacon technology. So that's how they know you're in the stores with the beacon.
I went and picked up some earbuds, scanned it, said buy, and then just left.
Right.
Without,
yeah. That's so you don't have to talk to a human. And really, I'm sitting there running. Are they going to attack? I'm in San Francisco, right? They actually have armed guards in San Francisco. It's a beautiful Apple store. I'm like, going to attack me. I'll walk out. But the beacons are normally stationary, and the use case is the one I just described, like the Apple Store Best Buy, all the retailers are going to roll them out for the exact same use case now. And Google's in the game. They have their own thing. Their Google, that's the iBeacon standard. The Google Beacon standard basically also produces a URL. So on your device, it'll actually give you a URL that if you click on, it'll give you a video or a coupon or, you know, so Google's doing their own thing with this. It's pretty crazy what's happening. And it's all Bluetooth Low Energy. So basically, we're going to be surrounded with Bluetooth Low Energy.
What do you find, besides retail, what do you find some of the biggest use cases are, the biggest emerging use cases are for IoT?
For IoT in general?
Yes.
So everybody loves to talk about all the consumer use cases. I want to get a Nest, and I'm going to get a drop cam, and blah, blah, blah. I'm not interested in any of those, quite honestly. I'm interested in all the ones where enterprises can make money. And that's a very odd perspective. Everybody's like, I want to wire my home, or wire my car, or wire my dog. My dog doesn't care. She doesn't want any of this stuff, trust me. But if you think of all the things you otherwise can never have known in the physical world as a software person, and it's kind of hard to use your imagination enough to go, oh my God, now I can touch the physical world. But if you look at anything that really still has physical things, right? So if you think of the UPS person who comes up to your door and delivers your package, you sign on to the little tablet thing, that's an early example of IoT and a connected device. But now you can know everything about that package as it's en route and as it finds its way to your door, if you want that level of granularity. If you look at, there's a division of FedEx that we worked on with a little project, and I have the videos on my hard drive. But FedEx has a small sub-team called Custom Critical. So FedEx is known for the 24-hour package, we'll get it there overnight, right? That's where it knows FedEx for. These guys will get it there within an hour. They'll guarantee it's at a certain temperature, that if it needs to be, because it might be a transplant organ, or it might be munitions for a certain organization. And so they do like hardcore government, they do hardcore medical. These are the hardcore guys. And so I had a chance to meet with the architect of their system. And literally every moment that truck and that package is en route is sending telemetry data back to headquarters. They're processing in real time, actually using the Drools rules engine, which is one of our technologies, one of the products I work on sometimes. And it's actually letting people know, because literally they're actually telling the person it's 10 minutes out. It's 9.5 minutes out. It's 9 minutes out. It actually does all the geofencing carefully. And again, it's a certain temperature, and it's still the same temperature. And if the temperature starts dropping because they sense that the truck is having some difficulty, they'll actually have another truck en route to meet it in flight, to move the package to the new truck and keep it on its way, and they'll maybe lose 30 seconds. That's how it's critical delivery, right? So that's an example. They've been doing this for years, though. But now all that technology is available to all of us for pennies or a dollar, a couple bucks. So that's just GPS modules and a cell phone connection and something like you see here on the table. $30 worth of hardware. Yeah. And you can wire up every truck you have. I don't know how many trucks you have. So it's really kind of hard to imagine all the use cases. It really depends on what industry background you have and what you've worked with before. In my background, I did a lot of manufacturing and distribution. So I was dealing with weighing orange trucks or robotics on manufacturing lines. I just did a lot of that in my software world. I didn't do a lot of banking transactions, and I didn't do a lot of traditional web commerce kind of stuff, selling books online. But there's a lot of stuff happening in this space. So my job here tonight was simply to encourage you guys to think about exploring it all, and hopefully you're inspired enough to go, oh, that was cool stuff. I want to try that Raspberry Pi thing. I want to try that Arduino thing. I want to see what I can interact with. And maybe you want to build a clock with your children, right?
Working on it. Almost done.
Yeah. Or maybe, and really, if you have a Girl Scout or a Boy Scout these days, they're all doing this. I'm not kidding, right? So literally, if you do have a Boy Scout or Girl Scout or Brownie or whatever they call them these days, they all have merit badges now for this technology. They're soldering, they're building stuff, and you probably should pay attention to that. Wait a second, my child now has programmed their own microcontroller. Oh, wow. But that's a big push right now throughout the US at least. It's like teaching kids all this next generation. Because children, of course, don't have the, like as a software person, you're like, oh, I don't want to touch things. And there's pokey things on here. You don't have a pokey thing. And I'm saying that was me. It took me a long time to start soldering. It's like, I don't want to burn things. When I had a soldering gun as a child, my father's soldering gun, I melted stuff with it. Right? Because it was fun. Now I'm like, oh, I can connect to things and make magic happen, right? Let the electrons flow and magic happens. Now it's like a whole new thing. A whole new world's been opened up to. But I think we're way out of time. If you have other questions, though, feel free to come up and see me afterwards. If you want to dig around through this stuff, we can play with it some more, and I'm happy to spend a little bit longer here. Ah, that's what I got there. Do you have any giveaways?
I've got, yeah, the 2 All Things Open tickets, so.
Do you have a?
Actually, okay, first hand up there. Here, the raffle wasn't working, so all right, next.
Maria goes to all the conferences. I actually see Maria at all the conferences, right?
Here, thank you. It's a code, just enter this in the, nope, don't look at the code.
Well, it only works for the first guy who gets there, right?
Yeah, so. All right, well, thanks, Burr. This has been great. I hope everybody's going to go out and buy a Raspberry Pi. Thanks to MetLife for hosting us. This place is awesome. All right, so I think we're all done. If you want to ask for questions, I think you might hang around.
We can be here every month. Right?
Thanks for the
Absolutely.
Yeah.
You're welcome.
So same place, same time next month.
Bring more toys, though.
Got have more toys? Okay. And I do have some business cards for Tyler. Is Tyler still here? I don't know if he's not. He's left here with